Yesterday we discussed how to solve for logarithm functions. Today we're going to discuss some properties and how to graph natural log. So let's first take a quick look at what the function y equals e to the x is. Remember that e is a rational number that is approximately 2.718. So if I take e to the 0, I'll get 1. E to the first, I'll get 2.718. So if I put in a 1, I'll get a little bit better than 2. If I put in a 2, I'll get 2.718. So I'll get 4, 5 point something. So you can see this is an exponential equation. If I put a negative 1, I'll get a negative 1 over 2.718, which is about a third. So if I put in a negative 1, I'll get a third. Negative 2, I'll get 1 over e squared. So I'll be an exponential function, and my function will be going something like this. So if I want to graph the natural log, remember that the natural log function and the exponential function, we write natural log is log to the base e. That's just a short way to write ln, is log to the base e. So e is the base, y is the exponent, and x is the argument. So again, you can see that these are going to be inverses of each other. So to graph the natural log, let's remember what e to the x is, and then this is the inverse. How do we find the inverse? We switch the x and y. So remember, this point was 0, 1, so I'll graph 1, 0. This point was 1, 2.718, so I'm going to go 2.718 up to 1. This point here was negative 1, 1 over 2.718, so I'm going to go over 1.2718 and go down to negative 1. And a logarithmic function is going to look like this. And then, so our parent functions will be looking like this. Anything that is a y equals a is going to make it thinner. ln x plus something will shift it in the x direction, and if you have a plus something on the outside, this will shift it vertically. There are some properties that you should know about logs, and again, these logs work for log to the base anything, but what you'll want to, in calculus, we almost always use log to the base e, and log to the base e we write as the ln. So almost all of your problems will be ln's, but know that they work for any log. So the first property that I want to remind you of is what is the ln of 1. And again, if you think about exponential, this says e raised to what power equals 1? Well, that would be a 0. The second property that you'll have to know is the ln of a product is the sum of the logs. The natural log of a quotient is the difference of the logs. And if we have the natural log of something raised to a power, we're going to bring this power down in front and call that n, whatever n is, and then times the ln of a. The last rule that you should know is the ln of e, and again, you can figure that out because that says e raised to what power equals e, and that will just equal a 1. So in tonight's homework, you're going to be asked to simplify some logs, you'll be asked to expand some logs, and condense some logs. So I'll give you a couple examples of those, and then you can work on your problems. The first thing I'm going to ask you to do is sketch some logarithms without a calculator. So what I've done is I've attached the parent function of ln of x here in a dash. And I'd like you to start off with that. Remember that we have the point 0, 1, and 2, e up to exactly 1, and then 1 over e down to negative 1 is what we call our parent function. Okay. Let's remember what happens with our shift. So at x minus 1, this will shift your graph to the right one. So if I put in a 2, I'll get the ln of 1, and the ln of 1 is 0, and 0 times 5 is equal to 0. So this will shift this equation over 1. The 5 will make this 5 times as tall. So again, if I put in e plus 1, I'll get the ln of e, and the ln of e is 1, and 1 times 5 is equal to 5. So this point's going to be 5 times as tall, and this point is going to be down to negative 5. So our graph without a calculator, you'll still have basically the same shape as an ln, but what will happen is it will be shifted and it will be bigger. And that's basically all you have to know for sketching. The next sets of properties the next set of problems are going to deal with properties. So those 5 properties that I gave you earlier in the notes, you want to look back at. So looking at these properties, you will see we're going to have a power, we're going to have a quotient, and I'm also going to, in this rule, apply the product rule. So this is going to be expanded. I'll kind of show you how this works. First off, we're going to expand and bring the 5 down. So this will be 5 times the ln of this quotient. And remember, quotient is the ln of the difference. So we will take this 5 will be multiplied by the difference form. We'll get rid of that in parentheses. And then we'll expand this one more time. So 5 times the ln of x squared minus 1 minus, now since we have a product here, this will be ln of 4 plus, why plus? Because it's a product, plus the ln of x cubed. Let's see if we can use our properties anymore. We don't have a property for the ln of a sum, so this will just be x squared minus 1. This will be, if I distribute through the negative, I'll get a minus ln of 4. But look here, we have another power. So we can also bring down that power. It will be minus, and this is expanded all the way. So one type of problems you're going to have to expand, and the other problems that you're going to have to look at today are condensing. So here, the problem we have here is that it's already been expanded. Now we're going to try to get this down to one ln function. So we're going to use our properties backwards. So first off, let's look at this power. Where did this power come from? The power came, or this 1/2 came from the power. So know that we're going to take the square root of this whole thing. We've got an ln of x squared plus 1 minus, so this tells us that this is going to be in the numerator, and this is going to be in the denominator. And if this is also a minus, this also tells us that this will be in the denominator. So we have 4 ln of x, but remember when we have a number in front, this really means that we have a power. So when we look at condensing, we're going to use our rules, and this 1/2, remember, came from the power. So you might see this written as the ln of the square root of x squared plus 1 all over x plus 1 times x to the fourth. So you're going to practice problems on page 329. I would like you to do 11 through 33, the odds, and then we'll ask questions tomorrow in class.